Quantum computing represents a paradigm shift in information processing. It's not just a step up in power, it's a completely different logic. While classical computing works in binary, processing zeros and ones sequentially, quantum computing harnesses the fundamental properties of matter. Its units, qubits, operate in superposition. This means they don't just choose between one state or another, but rather explore a vast number of combinations simultaneously. This capability allows us to tackle exponentially complex problems. Challenges that would require impossible execution times for a conventional computer, or be entirely unsolvable, become computable and practical in reasonable timeframes under this new physics. Since 2018, here at CTIC, we've been turning this theory into practice. We operate out of Asturias, collaborating with key players like Nanomaterials and Nanotechnology Research Center, CIN, and the Quantum and High Performance Computing Group at the University of Oviedo, though our impact extends far beyond. Nationally backed by the CDTI, we coordinate the ARCA Network of Excellence and its evolution, ARCADE, spearheading quantum research in Spain. This new phase expands our alliance to 5 technology centers across Asturias, Galicia, Castile and León, Catalonia, and the Valencian community, focusing our solutions on defense and strategic civilian sectors. Furthermore, we are plugged into the country's most powerful infrastructures, such as the Skyle Supercomputing Center and Zesga's Cumio quantum computer. But for research, we need our own muscle. That's why the heartbeat of our quantum lab is Qt, our high-performance quantum simulator. After a crucial period hosted on the Isaac supercomputer, its latest version leaps to the next level of power, alongside its big brother, Atlas. This upgrade allows us to emulate circuits of up to 38 qubits, validating complex algorithms before running them on actual quantum hardware. But what is all this power for today? At CTIC, we apply quantum technology across 3 main areas. First, quantum artificial intelligence. We fuse machine learning with quantum computing to classify satellite imagery in projects like ARCA. With ARCADE, we apply this technology to automatically identify vehicles, infrastructure, or individuals during surveillance missions, detect cyber attacks through anomalies in IoT systems, or spot crop diseases, just like we do with Freskia. We are even applying quantum generative AI to verify biometric signatures. Second, optimization. We solve problems involving thousands of variables where classical computing simply gets stuck. From optimizing the deployment of drone swarms and last-mile logistics routes, to the efficient management of energy communities. Finally, security. The rise of quantum computing puts current cryptography at risk. At CTIC, we are acting on 2 fronts. On one hand, in post-quantum cryptography, where we design roadmaps based on crypto agility. This allows organizations to transition effectively to protocols that can withstand quantum attacks. And on the other, in quantum key distribution, or QKD technologies, we are designing communication architectures with absolute theoretical security, capable of physically triggering an alert if someone tries to intercept the key exchange channel. All this research translates into tangible results. Thanks to the application of quantum technology in our quantum lab, we have drastically reduced model sizes and training times, while boosting computing capacity for critical problems and energy resource optimization. We don't just accelerate processes, we transform complexity into a strategic, sustainable, and sovereign advantage, ready to lead the challenges of tomorrow.